Okay, these ones you'll see a lot. These are not unit circles, but you have to use your triangle 45 degrees, 60 degrees, and 30 degrees to solve it. I'm not sure what stage your teacher is at, but there eventually you produce a exact trig value table, and it looks a lot like, let's see if this. This is more the advanced one that you'll see. And then this is the one you'll probably have, let's see, this one in the beginning. This is very likely in the beginning. Let's try this. This advanced one, you'll notice that there's no, I called this one up here the advanced one. You'll notice there's no square roots at the bottom. Generally speaking, we don't want square roots at the bottom. But this one, you can see 1 over square root of 3 instead of square root of 3 over 3. And one day I'll explain that. So we'll just use this one down here instead, because it's the one that you most likely have. And you get these values by working out the trig values from those 45-degree triangles and 30-degree triangles. Let's have a look at this one. First of all, note that the x and the y are both positive in this one. So our first step is drawing a Cartesian graph, and you'd have it spaced out properly. And you'd have the point 1, 5 up here. So that's 1, 2, 3, 4, 5. And notice that when you draw it by hand, it's inaccurate. So I always encourage you to either go get some graph paper that you can draw on, or use something like this, Desmos, which is a very valuable tool for all of advanced math. And you can always just copy the image like that, and then you'll get a more valuable graph. And then now our next step is you always want to, I didn't do it properly there. There we go. I'll just grab it. There we go. Now our next step is you will want to draw a line to origin to that point. You will simply want to label your triangle. And now you always create your right angle triangle by drawing straight down to the x-axis, not to the y. And now based on this, you'll note that this length of the bar can be figured out, because that's how far out to x we went. How far out to x did we go? 1. That means the length of this triangle here is 1. And the height can be figured out because we went up to 5. So that's there. And thus the hypotenuse can be figured out because the hypotenuse is a squared, 1 squared, plus b squared, which is 5 squared, which ends up being 26. So the hypotenuse squared is 26. Or if you want, the square root of 26 is the hypotenuse. So you want to put that there. Now note that all values are positive, but the hypotenuse will always be positive. And that's because when you square a number and add it to another squared number, it's going to always turn out as positive. But this means that for this angle here, which we do not know and does not matter, we will just call that angle A. Okay, that's the angle we're concerned with. And from this, we go to SOHCAHTOA. And we learn that sine of this mystery A angle is equal to the opposite over the hypotenuse. Well, you just figured out the opposite. It's the opposite side is 5, and the hypotenuse is the square root of 26. So right there, we have already figured that out quite easily. I'm just going to do the fractions and the square root later. And of course, based on cosine is of angle A, is the adjacent side over the hypotenuse. The adjacent side is 1, and the hypotenuse is square root of 26. And finally, the tangent is the opposite over the adjacent side, which is 5 divided by 1, which is simply 5. At this point, the other trig values, if your teacher has moved on to the other trig values, they're also easy to figure out. Square root there, that's a really bad square root, but what can you do? A little bit better. Square root there. And don't forget, we've got a fraction here as well. There we go. Now, you're going to learn that cosecant, which is abbreviated as CSC, of angle A is the flip of sine. You're going to learn that secant spelled like that or abbreviated like that, of angle A is the flip of the cosine, and finally cotangent is the flip of the tangent. So what's the flip of 5 over 1? It's 1 over 5. Always remember that whole numbers have an invisible. They're invisibly over 1 always. So cotangent's this. I'm going to use this template here for the other ones. This one's going to go up, and the one I can steal from there is easier. There we go. I'm going to use this template for over here, except the 5 is going to be at the bottom, and the 26 is at the top. So there we have all 6 trig values from this. And that's exactly how you do it with all of them. But note that as we enter into these negative coordinates, it's going to be important to note where those are. Let's do the same trick and steal 4 comma minus 3 here. And there we go. That's 4 comma minus 3. And we'll do the same thing we just did. We'll get rid of these, but we'll keep the cosecant, or sorry, the trig equal signs. There we go. Now we do the same thing. We go from origin down to this spot. Note that it's almost 45 degrees if they were both 4 minus 4. They're not. And then we're always going to create our right angle triangle by going straight up to the x-axis. And then we're always concerned with this angle here, angle A. And note that the opposite is always going to be the y. Now, lengths are always positive, but I want you to note that it's really minus 3, and it's okay to mark it as minus 3, but lengths are always positive. I'll explain why the minus is important in a second. And the 4 over here is the x value, obviously. And then finally, to figure out this, it's the square of 4, which is 16, plus the square of 9, which is square of 3, minus 3, which is 9. And that's why it comes out positive. Minus 3 times minus 3 becomes a positive number. 9 plus 16 is 25. And the square root of 25 is 5. And you'll discover this ratio always when it's 3, 4. This is always 5. If this was 6 and this was 8, which is double, this would come out as 10. If this was 9 and this was 12, this would come out as 15. But 3, 4, 5 is a very common thing. Now, let's focus on angle A. Sine is the opposite over the hypotenuse. Cosine is the adjacent. Okay, the adjacent side is 4 over the hypotenuse. And tangent is the opposite. Here's where it's, oh yes, yeah, here's where this has come in. Minus 3 over the adjacent, 4. Now I want you to note something. Tan is negative. Sine is negative, minus 3 over 5. Cosine is 4 over 5. And the reason for that is the x value is positive and the hypotenuse is always positive. And that is why we say that C, that's why we use C, A, S, T. It means cosine and secant are always positive in this quadrant because the x value divided by the hypotenuse is always going to be positive. That's why we have the cast system. Okay, so what about the flips? Well, this is 5 over 3 for this one. Even though the minus 3 goes to the bottom, you never really leave that minus 3 at the bottom. You always have the minus at the top. So even though it's 4 over minus 3, we would move that minus up here, and it's really minus 4 over 3. There we go. And then for this one, it's simply 5 over 4. We can see that the secant is also positive because the flip of a positive fraction is still positive. And then finally, we're going to steal this 5 because it's still a 5 for here, but it's going to be minus 3 down here. And same rule, you can't have the minus down below. So we migrate it up. So we can see that in the flips, this cosecant is minus. We can see the cotangent is minus, and the secant is positive, which is, again, why we have the C cash rule. They're all figured out like this. I don't think you need me to do the other ones, See how you do. If you can't do it, let me know. And we'll go to the next question. Oh, it's in there it is. Determine the exact value. So here we're going to need our triangle. We didn't need it for the last one, so that was my mistake. We'll need our exact value table. I'll take these, do that, and we'll keep our exact values. We'll get rid of this, and we'll just zoom in a bit. Okay, to figure this out, we actually have to figure out this angle over here. And if you look, it's 180. How much, if this is 180 to here, and this is 135 to here, how much is that extra angle? Well, it's clearly 180 minus 135. It's 45. So really what we're talking about here, if we draw the line straight down, is a right angle triangle where the angle here is 45. At that point, I now know my angle that I'm working with. I would put in CAST to realize that both the sine and the secant in this quadrant are positive, everybody else is negative. At this point, I would take my exact value table, which is figured out from those triangles I tried to teach you how to draw. And I would work with them, and I would find 45 degrees. And I would say, okay, well, there's 45 degrees. Square root 2 over 2. Oh, this one has the weird ones written. It's before you figure out how to do that, it's really 2. Let's see, I think it's 2 over square root of 2. Let's figure it out. So 45 degree triangle, where this is 1. Therefore, if they both equal 1, it's half of that. It's half, I think, and a half. Does that work? Quarter plus, no. So if a squared 2a squared is equal to 1 square root of, it's 1 over square root of 2. Well, you can do it this way too. You can make both these sides 1. That means this is a 45 degree triangle. And 1 squared plus 1 squared is 2. Therefore, the hypotenuse is square root of 2. And we can figure out all the values. So sine is opposite over hypotenuse. So it's 1 over square root of 2. And you might ask, well, how come this table here says square root of 2 over 2? Well, we never want square roots at the bottom of a fraction. So what they do is they want to get rid of that square root. Well, you can multiply a fraction by 1, and it's not going to change it. And you can multiply by variations of 1. This is how you change denominators. That's still 1. So even though I multiply this fraction, it doesn't change. But what happens if we make, instead of 2 over 2, we make it square root 2 over square root 2? Well, 2 times square root of 2 times 1 is square root of 2. Square root of 2 times square root of 2 is 2. And that's how you get this. That's how you convert this into that. So your teacher, if your teacher's probably going to want these, I don't know, but this is a valid answer for sine, or this is a valid answer for sine. So to answer the first question, the sine of this 45 degree, or sorry, sine of 135, I can see that we're in the S quadrant, therefore it's going to come out as positive. So my answer would be 1 over square root of 2. Sorry about that. Or square root of 2 over 2. So sine of 135, because it's positive. The answer is just stolen from the table, but the table comes from the triangle I just drew, like that. Although when you're first learning this triangle, it's really this, 1 over square root of 2. And to confirm that we got it right, well, 1 over square root of 2 is, what is 1 over square root of 2? 1 divided by the square root of 2 is equal 0.707. So to make sure that we got it right, you take 135 and you hit sine, and you discover that you did indeed get it right. Which means the flip of this, the secant of 135, is going to be the flip, 2 over the square root of 2. This. There we go. Now let's look at our cosine. Well, my cosine of 135, or 45, is normally square root of 2 over 2. It's the same one, 1 over square root of 2 over 2. 1 over square root of 2, or square root of 2 over 2. This is one of the few times that the numerical values will be the same as 45-degree triangles, with one exception. Remember that I said only sine is positive in this quadrant and secant? Therefore, we have to slap a negative outside of it. And, of course, the cosecant. Sorry, this is not secant. This should be cosecant. I don't know what's in. This is the secant. This one up here is the cosecant. Therefore, the secant of this is the same as up above, but has a minus in front because we're in this quadrant. And then I'm just going to ignore this. There we go. And then finally, the tangent we can see from this table is 1. Therefore, the tangent of 135 is negative 1, because we're in the quadrant where only sine is positive. And if I flip negative 1 upside down, negative 1 over 1 is what the fraction is. If I flip it, I get 1 over negative 1. But we never write that like that. We write it, we put the negative at the top, and negative 1 over 1 is simply that. So this is one of the few times the cotangent is the same as the tangent. And there we go. So there, we figured that out. They're all the same. You do it all the same like this. Keep the equals here and the exact value. So if you look at this one here, I need to figure out the angle between the x-axis and the terminal arm here. It's called the acute angle. And if I go all the way here with the terminal arm at 180, how much more do I have to add 180 to get 240? Well, it's 60. So we're really talking about the 60-degree triangle. But we also have to realize C, A, S, T. Only tangent's going to be positive in this quadrant. I'll explain why sometime, but right now we're just going to try to get the answers done. Well, that means tangent of 240 is the same as 60. Sorry, sine of 240 is the same as sine of 60. We can see that the sine of 60 is this. Maybe I'll just steal these over here. Yeah, well, no. We're working on this one now, so that's fine. Oh, I see why. Yeah, I can't do it. There we go. We'll just steal that, and we'll put 240 wherever I see 35. There we go. So the sine of 240 is the same as sine of 60, except I'm in a quadrant where this must be negative. So I'm going to steal this little negative bar here, put it there. Get rid of any positive sign. And there we go. And then cosecant's the opposite. We're going to put the negative in front of the 2, though. And the square root of 3 goes at the bottom. So the opposite trig values are just the flip. The ratio. And then cos of 240, we just take it from the 60 here. It's 1 over 2. And cos also in this quadrant is negative, so we have to use a negative bar here. There we go. And the flip, the 2 is just up top. The negative value there. There we go. And we'll put the 1 at the bottom. Well, negative 2 over 1 is just negative 2. And then finally, the tan of 240 is the only positive one. I go to 60. I see it's a square root of 3, and this is the only time that it's positive because we're in the tan quadrant. And then the flip of that is 1 over square root of 3. Now, technically, your teacher might not want that. So you have to multiply by square root of 3 over square root of 3. And what you get is square root of 3 over 3. And because we're positive, we're in quadrant, whatever, this is the official answer that your teacher will probably want. So there you go. That's how you figure out all these. They're always the same. Figure out the acute angle and refer to the table, then adjust for cast. And these are always the same. Draw it on the Cartesian, figure out which one's negative and which one's positive, and you can use cast to do it as well. This last degree, how much more to get to 360? This angle we're talking about is 30. Without a calculator, state whether each ratio is positive or negative. That's pretty easy enough. It just depends what quadrant it falls in, and then you can just use the cast. So just take a Cartesian graph and figure out which quadrant these fall into. We know that this quadrant is going to be from 0 to 90. This quadrant is going to be from 90 to 180. This quadrant here is 180 to 270. And then finally this quadrant here is 270 to 360. So I'm going to just mark these in color codes. What quadrant does this fall into? This one. What quadrant does this one fall into? Same one. What quadrant does this one fall into? This one. And what quadrant does this one fall into? The same one. So what we could just do is mark them as the same color, really, if you wanted to. Okay, now we just use the cast. C-A-S. Only sine's going to be positive here. Only cosine's going to be positive here. So this falls in the red, so it's positive. This falls into the red, only sine is positive, so that's going to be negative. This falls into the blue, only cosine is positive, it's going to be negative. This falls into the blue, only cosine is going to be positive, so that's negative. Without using calculus, which ratio is positive or negative? So it's positive, negative, negative, negative. It's all based on cast. Stand to determine the exact values. Okay. You might say, well, there's no way to figure this out. And this is one we're using SOHCAHTOA. Okay. So they're telling us right away it's in quadrant 3. This is 1. This is 2. This is 3. So now we're using our cast system. C-A-S-T. That means only T. Only tangent and cotangent is going to be positive. It's clear that this is negative, so that means they want me to, an angle's in standard position with its terminal arm at the stated quadrant, determine the exact values for the other two primary trigs. So that's for cosine and sine. So since it's down here, it must fall in here like this, right? It's got to. Okay. Well, we draw a triangle straight up. There's my right angle. And like that. Okay. Now, what is sine overall? Well, sine, according to SOHCAHTOA, is so. So the sine of any angle is going to be the opposite divided by the hypotenuse. Well, they've given me this. So one thing I could say is this must be the opposite, and this must be the hypotenuse. I can then put them there like that if I want. And minus 3, of course, is minus because I'm in the negative y quadrant. And guess what? My x is also going to be negative because we're to the left of origin. But the question is figuring that out. Well, at this stage, you would use Pythagoras' theorem. We know that our mysterious x value squared plus our y value squared, which is minus 3 squared, which is 9, is equal to our hypotenuse squared, which is 5 squared is 25. Now I just got to get x squared all alone because it's got something added to it. I use reverse BEDMAS. So I get x squared is equal to 16. And so I got to take square root of both sides. Now here's a little tricky thing that people don't necessarily explain. When I take a square root of any number, sure, this square root gets rid of this square, so that's fine. But there's two possible answers to the square root of 16. It's minus 4 and 4. And you might say, why? Well, because 4 squared, or 4 times itself, is 16. But minus 4 squared times itself is also 16. So minus 4 times itself is also 16. That's because a minus number squared comes out positive. So the square root of 16 has two answers, minus 4 or 4. We just got to figure out which one is applicable. Well, we know we're in quadrant 3, where all x values are negative. So that means this adjacent here is actually -4. Now I can figure out all my other trig values. So I have to take my adjacent to the angle. That's -4 over the hypotenuse, 5. Tan, I have to take the opposite, which is -3, over the adjacent, -4. Here's where you're going to learn why tan is always positive. A negative divided by a negative is a positive. And that's why tan and cotan are positive in this sector. It's because when you take the opposite divided by the adjacent, they're both negative and become positive. All the rules for cast derive from the xy values in these quadrants. XY values here are plus. That's why all angles in this, all trig values in this quadrant are positive. X values here are negative and positive. That's why only sine is positive here. Sine is dictated by the opposite, which is always the y. And all other values are negative. Both x, y are negative here in this quadrant. And over in this quadrant, it's plus minus, which is why, this is why all tangent and cotangent's positive. And over here, that's why cosine and secant are positive. All other values are negative. And it all has to do with taking the opposite divided by the hypotenuse or the adjacent. And depending on what the opposite are positive or negative here, that dictates the result. Do you need me? I'll do it again for this one. That was quadrant 3. This next one's quadrant 4. And in quadrant 4, we know from cast, C-A-S-T, that C, cosine, is positive. That's why it's positive. And then if we draw this thing over here with the terminal arm go up, there we go. Well, they've given us cosine, and cosine, I know from SOHCAHTOA, is the adjacent over the hypotenuse. And they've told me that it's 2 over 3. Therefore, I know the hypotenuse is 3 and the adjacent is 2. Now, whatever value this is will be negative because we're in this quadrant where y values are negative. How do I figure it out? Well, y squared, whatever y is, plus 2 squared, which is 4, is equal to 3 squared, which is 9. Y squared is equal to 5, square root both sides, plus or minus square root of 5. Since I'm in the negative area for y, it's negative square root of 5. At that point, after figuring out cosine or figuring out all the values from the cosine they've given me, I can say that sine is equal to the opposite, square root of 5, over the hypotenuse, 3. Tangent is equal to the opposite, negative square root of 5, rather, over the adjacent, 2. So these are the potential answers. I got to put a negative there, and it's square root of 5. The negative is outside the square root of 5 because you can't square root a negative number. And there we go. But you can multiply the result of the square root by -1, which is what's going on here. So again, the answer is minus the square root of 5 over 3. And for this tan, it's minus the square root of 5 over 2. Yeah, this one's, over 3, and that's the adjacent over 2. If you were to put this in your calculator and figure it out, it's going to give you the same values if you asked your calculator to figure out this angle, but we don't have the angle, so we don't know. However, you could easily figure out what angle this is from the 2 over 3 that they've given you for cosine. Say, okay, well, 2 divided by 3 is this. I'm going to hit the inverse cosine and discover the angle they're talking about is this. And you notice that you could say, wait, 48.1826 degrees is not in this quadrant, it's in this quadrant. And that's because your calculator will always spit out quadrant 1. To figure out if they were to ask you what the actual terminal angle is for this, you'd have to go all the way around. And you'd realize that this little angle here is 48.18. And you would just take 360 minus this to figure out the terminal angle. I'm just going to cheat a little and subtract 360 and make it positive. So this is the actual angle they're talking about. That's the terminal angle. So if I were to take the cos value of that, I'm going to get 2 over 3, or 0.66. There we go. So if they ever ask you the angle, you can figure it out. Solve each equation. Note that they give you a range. This is for the full circle. So we have to figure out what angle they are without using a calculator. See, using the special triangle. So in this case, you'd have to know your special triangles. I assume you can't use the table, or they haven't given you the table, which means you have to learn how, oh, your teacher has square root at the bottom, so that's good. So these tables that I showed you over here have been adjusted for square root at the top. It's possible to find one that hasn't, though. Let's see if that one has some of them at the bottom. Yeah, I think this one does. But I don't think in this case your teacher wants you to use these tables. I think he wants you to derive from the special triangle, but you can always consult the tables to see if you got it right. So let's figure out what angle they're talking about here. Well, we're either talking about the 45-degree triangle or the 60-30. Let's start with the 45. 45 is right angle. Both sides are 1. Boom. 1 and 1. 1 squared plus 1 squared is 2, so this side is square root of 2. I see some 1s and square root of 2s here, so we're probably talking about the 45-degree triangle, because the sine of the 45-degree triangle is 1 over square root of 2. However, this is a negative. This is the positive, so if I were to draw my 45-degree triangle here, I'd see that in this quadrant, sine is positive. See, A, all values are positive. Over here, the 45-degree angle would be not 45, but 135. And again, sine is positive. And then down here, t is negative. So this, because it's negative, is in this quadrant or this quadrant, because there's two possible negative answers. So the question becomes, what is 45 degrees in those two quadrants? What is 45 degrees in those two quadrants? Well, 45 degrees here is always between the x-axis, 45. If I go to here, it's 90. If I go to here to 80, 180 rather, 180 to 45 more, well, we're talking about the angle 225. But that's not the only angle that can come out with this. Over here, there's a 45-degree angle here between the x-axis and the line. And 45 there is 360 minus 45. And that terminal angle there is 315. So the two possible answers are 225 or 315. As we found out before, we can easily prove this. What's 1 divided by square root of 2? It's 0.707. So the big question is, does the sine of 225 come out as negative 0.707? It does. Does the sine of 315 come out as negative 0.77? It does. 707 does. So there you go, those two possible answers. Now let's look at this one. Well, it's positive. It's positive. So C-A-S-T, positive there, and tangent's positive there. So we're talking about quadrant 1 or quadrant 3. Okay, well, we know in quadrant 1, that's going to be easy. That's just going to be the special triangle that we figured out. But this one over here is going to be 180 plus the special angle that we figured out. Notice it's square root of 3, and there was no square root of 3 in our 45, so we're talking about the 60 degree. How do we figure out the 60 degree? You draw a triangle that has equal sides, and you use 2. You know that if it's all equal side, they're all 60. We're going to draw a line straight down. That changes this one side here to 1, and it changes this angle up here to 30. But that means we're going to redraw it like this. 160 and 30. And we just have to figure out, is the tangent of 60 square root of 1 over square root of 3? Or is the tangent of 30 1 over square root of 3? Well, we discovered that this side here with some Pythagoras working is square root of 3. So let's figure out if the tangent of what the tangent of 60 is. Well, the tangent of 60 is opposite over adjacent. That's TOA. Well, that's square root of 3 over 1. No, that's not 60. Automatically, you'd know it's 30, but let's just make sure. TOA says it's the opposite side, 1, over the adjacent side, square root of 3. So there, sure enough, we're talking about 30 degrees. But remember, we're in either quadrant 1 or 3. Well, 30 degrees in quadrant 1 is always just 30 degrees. The terminal angle in this quadrant is always 180 plus the acute angle, which is 210. So my answer is 30 or 210. And if you were to punch those in your calculator, you'll get the same answer. Let's look at a little simple rule about how to figure out the quadrants. This quadrant's always going to be 180 minus the acute angle. This quadrant is always going to be acute angle 180 plus the acute angle. And this last quadrant over here is always going to be 360 minus the acute angle. So that's how you can always just do it. Once you figure out the special triangle that's being used, you either figure out your quadrant. If it's quadrant 2, it's 180 minus the acute angle. If it's quadrant 3, it's 180 plus the acute angle. If it's quadrant 4, it's 360 minus the acute angle. These things all are solved the same way. You can go ahead and do these yourself. This one, again, is for the full circle. Notice that we're talking about this. Whenever you see decimals like this, they want you to use your calculator. Just be aware your calculator is going to spit out either quadrant 1 or quadrant 4. I know I always said quadrant 1, but when it's a negative value, it's going to spit out the other quadrant. So let's try to figure out what angle we're talking about here, and that did not help at all. And how to do these. These you'll have to use your calculator. Okay. So please note that this is a positive value. Sine can only be positive in quadrant 1, C, A, and quadrant 2, S. So we're really only worried about quadrant 1 or 2. How do we figure that out? Well, we have to do the arc sine of that. Arc sine of 0.7, is it 0.776 so? Because it's not going to be a special triangle, is this angle. Well, we know in this quadrant, that's just the acute. 50 point, let's call it 9, even though this is the actual answer. But in this quadrant, it's all the way to 180 and then back to figure the terminal. So it's 180 minus that value. I can always do that value minus 180 and then just take the positive value of it. So really, this angle over here, starting from here all the way to there, that full green angle is 129.14. And you can be sure of that by, if you were to punch this into your calculator and press sine, you will get 0.7760. See? So that's how you figure it out. Now, there's always going to be two angles when it's positive. There's always going to be two angles when it's negative. What about this one? Okay, well, we have to take the arc cosine of this negative number, but let's review cast C, A, S, T. Well, cosine would be positive down here, negative here, negative here. So this angle is in either quadrant 2 or quadrant 3. Here or here. Well, remember that that area is going to be 180 minus the acute angle. And this area is going to be 180 plus the acute angle. But because my calculator must spit out the result of the negative, it's going to spit out the one that's closest to 0, and so I think it's going to spit out this one. Let's figure it out. Let's take the arc cosine of negative 0.8090. Trig, arc cosine. We get this 143.9998. If I were to round up, or wanted to round up, I'd really be talking about 144. Try not to round up unless your teacher tells you, though. So it spat out, obviously, this one, because 144 is just past 90, but before 180, so it's that one. So the question is, what's that acute angle? Well, that acute angle is 180 minus 144. That acute angle is 36. So that means to find this acute angle, it's also 36, but to find this terminal angle, which goes all the way to here to there, is 180 plus 36. So really, it's talking about 180 plus 36 is 216. Now, don't use the 36 that I just used. Use that. It'd be 180 minus that, so you're going to get 36.112. And then you have to do 180 plus 36.1112, so it's going to really be something like that. And that's how you figure out that. Always the same method. Once you figure out the methods, it's always the same. Is this true or false? So really all you have to do for figuring this out is cast and the acute angle. Justify your answer. Okay, well, our justification is going to be from cast and the acute angle. So first of all, notice that they're asking us if they're going to be the same, but negatives can't be the same. So let's figure out what quadrant 120 and 210 is. Well, 120 is more than 90 and less than 180, so the sine value is going to be here. The cosine of 210 is more than 180, but less than 270, so it's going to be here. Well, according to CAST, C-A-S-T, sine is positive here, and cosine is going to be negative here. Only tangent's positive. Therefore, this cannot be true. Right away, I can say can't be true. Even though their acute angle is both 60. Now, actually, their acute angle is not even 60. Their acute angle is 30 and 6. That's 60 acute angle. So the other argument you can make is 120, which goes from here, forms an acute angle of 60, and 210, which goes to here, the distance from 180 is 30. While you can have some values of cosine equaling the values of sine for that, it is impossible to have a positive value for here and a negative value for here. Therefore, they can't be equal. To prove this, you can just take the sine of 120. You see 0.8666. And then you take the cosine of 210. Now it's going to produce a similar number, but it's going to be negative 0.8666. Then when we look at this next one, let's look at this one, 270, even though they're both acute angles of 10 degrees, because 170 goes to here and forms 10 between the x and the y, and 350 goes to here and forms 10 degrees between the x and the terminal arm, rather. Let's look at cos. So C-A-S-T. While their numbers will be the same result, the cosine values in this one are positive, and the cosine values in this one are negative. Therefore, they cannot be equal. Now let's look at this next one. Sine, where is 200 degrees? Well, 200 degrees is just past 80, so it's forming 20 degree acute angle. 340 is just before 360, so it's forming a 20 degree over here. So the 20 degrees, check. Now we only have to do cast, C-A-S-T. Well, over here, sine will be negative because only tangent is positive. Over here, sine will be negative because only cosine is positive. Therefore, since they're both acute angles of 20 and they're both negative in these quadrants, they will be equal. And you can confirm that in your calculator. Now, the last one might be tricky. Yeah, this next one is going to be tricky. So it's 150. Where's 150? It's in this quadrant. It forms an acute angle of 30. 300 is over here, and you might say, well, it's disqualified right away because it's an acute angle of 60. However, what's interesting about 30 and 60, because they share the same sides, is the numerical value of sine 30 will be the same as the numerical value of cosine 60. So you have to be careful. We have to go to cast here. C-A-S-T. We discover sine is positive here. And we discovered cosine is positive here. So it can be the same value. If we use our 30-degree triangle, or in our 30 and 60, like this, there we go. We discover these in our special triangle. It's square root of 3 here. It is 2 here and 1 here. We discover that the sine of 60 in this quadrant is square root of 3 over 2. So the sine of 60 is square root of 3 over 2. The sine of 30, because we're talking about 30 here. The sine of 30 is opposite over hypotenuse. It's a half. And we discovered the cosine of 60. Here's cosine. It's the adjacent over the hypotenuse. It's also a half. Since they both have the same numerical value and they will both fall in a positive zone, they are equal. That's the only one that's equal. And we've justified our answer. And that's it. There you go. That's how you do those. You always do these things the same way. It's just learning when it's true and what's not. Yeah. Yeah, so there's the justification there.